Frequency distribution tables are very handy because, very simply, they tell us what frequency each one of the scores occurs with in our distribution. However, just knowing what a frequency is, like having 4 fours, knowing that it's 4 fours doesn't really give me any idea as to whether or not the value of 4, whether or not having 4 siblings is common or uncommon, unless I then look at my whole list of frequencies and see how that 4 compares. 4 seems to be kind of a very normal sort of response, whereas having 6 siblings, there's 1 out of, it's hard to see here exactly unless I sum these all up, but this looks like it's about 20. Actually, I think we worked this out before, that this was 28. The sum of f is 28. Then I can see that having 6 siblings, at least in this data set, is a very rare occurrence. So rather than have to do that with each one of these, as I'm looking at my table and trying to determine what's happening with each one of these scores, or get a feel for how common or how rare each of these scores is, why not work it right into the table? And so this is where proportions come in. A proportion does exactly what I just sort of did verbally. It takes a frequency and it divides it by n. Now we know that n can be determined by summing up your frequencies. And just to make sure I didn't mess this up, I want to add these up again and make sure that it actually is 28. So 1 and 4, that makes 5. Another 3 makes 8. 10 gives me 18. And then add the 7 and the 3, yeah, that brings it up to 28. Okay, so in order to get this proportion, I'm going to work out my frequency, which is 1, over n, which I know to be 28. And so let's see, what does that end up coming out to be? 1 divided by 28. My proportion, sorry, that's hard to see. My proportion is 0.0357. I'll go to 4 decimal places. So this is 0.0357. Now, this number is, a proportion is always measured between 0 and 1.0. And the closer you are to 0, the more rare something is, the less of a probability that it's going to come up. So this is a fairly small number, let's say by comparison to the 10. 10 divided by 28, this one here, the chance or the proportion of times that a 2 came up in our survey was, the proportion for that one is going to be 10 divided by 28. And so this is 10 divided by 28, that's 0.3571. 0.3571. That is, not surprisingly, 10 times the proportion. Notice that we went from a frequency of 1 to a frequency of 10. So the frequency is 10 times larger, the proportion is 10 times larger. Still, though, it's a little bit hard to make sense of this number. Instead, we change proportions into percentages. And to get a percentage, you very simply just take your proportion, multiply it by 100, and you get the percentage of times that this particular score showed up in your distribution or in your sample. So my first proportion, when I multiply this by 100, I get 3.57%. So that makes it a little bit easier to understand what's going on. Let's go through and do that for each of our values. And then we can have a look at just how rare some of these occurrences are in more solid terms, like percentages. Okay, so 0, that one's easy. 0, so that's my frequency. Divide that by 28. 0 divided by 28 is still just 0. And so that would be 0%. Let's do everything to 2 decimal places here. 4 divided by 28 is going to be how much? 4 divided by 28. It's 0.1429. I'm going to round to 4 decimal places. 0.1429. And so this is 0.1429. So this is 14.29%. And 3 divided by 28. That's 0.1071. And so that's going to be 10%, or a little bit over 10%. Here we've already worked out our proportion. Multiply this by 100 and you get our largest proportion or percentage, 35.71%. And then 7 divided by 28, I think that one is a quarter. Let's just double check. 7 divided by 28, yeah, that's 0.25. 0.25, and so this becomes 25.00%. And then finally 3, we already did that, or we already did the math on that up above when we had a frequency of 3 here. We've got it again here, and so this is 10.71%. Okay, so I'd say it's easy to see that percentages are much more intuitive. You can see right away that the highest one, my highest frequency, leads to my highest percentage, and it gives us an easy way to describe what's happening with our scores. We can say that about a third, or 35%, almost 36% of our data set answered that they have 2 siblings, whereas only 3%, between 3 and 4%, said that they had as many as 6 siblings. So that's how you find proportions. And percentages, a percent is just equals to a proportion times 100. So these are the 2 formulas that I made use of to fill out these 2 columns here on the frequency distribution table. Now, whether or not you need to include these is typically just going to be up to the wording of the question. A frequency distribution table is literally just these first 2 columns here, the list of scores, or the scale of values that your scores are going to fall on, and your frequencies. If you're going to be doing proportions and percentages, that's going to be because they've specifically asked you to do that. So normally you don't have to put these on. It can be helpful if you're creating your own table for your own purposes to be able to see what percentage each score occurs with. But again, these 2 columns are really just here for you to use when you are specifically asked for them.